In first and second grade, as students continue to explore and play with addition and subtraction, some common strategies that I have seen in classrooms, I've seen students use, try to think about and reason with, and I've seen some instruction around, but also often lead to some confusion as students sometimes try to think of them as rules or processes or strategies that they should memorize and not necessarily ways that they should reason, are the compensation strategy for addition and the common difference strategy for subtraction. So we're actually going to look at them together to kind of highlight their similarities, why we've got just compensation as working for addition. It's a way that we reason and think about addition, and then the common difference is a way that we reason and think about subtraction. They're actually very similar strategies. If we were talking about and dealing with negatives, we could actually show how they are the same strategy, but they do play out, and the rules look a little differently if we were to apply them in, say, an equation type of a model, which can lead to some confusion where students just try to memorize, well, when I add, I follow this rule, and when I subtract, I follow this rule. But when we think through the reasoning, and we'll continue to use the open number line to show that reasoning, I think you'll see how this strategy can be helpful in developing the reasoning around addition and subtraction with the range of numbers we're dealing with in first grade, that within 100, and the range of numbers we're dealing with in second grade within 1,000, but also not to confuse students with more rules or things to memorize. So we'll start with compensation. So the first two examples here are addition, so we can use that compensation strategy. The first one aligns with first grade. It's within 100. So we're going to look at 59 plus 32. And I'm going to start on an open number line. So I'm going to start with 59. We could start with 32 if we wanted. With this strategy, it actually doesn't matter too much which one we start with, but because I know how I want to play with this strategy, I'm going to start with 59. So I'm going to start with 59, and my goal is to add 32. But instead of adding 32, the first thing that I want to do is just add 1 and get to 60. I just want to add 1 and get to 60 because 60 is a really friendly number. This is similar to some other friendly number type strategies. It's rooted in the same concept. It's rooted in the same reasoning. But what we want to think now is, well, instead of adding 32 to 60, I don't want to add 32 to 60 because that would give me too much. I was supposed to add 32 to 59. I'm going to add instead 31. And instead of adding 32, I add 31, and that's going to give me the same sum. But because I'm going from 60, the addition is a lot more simple, a lot less complex. There's no regrouping involved, and so 60 plus 31 is 91, and we get our sum here. That's the compensation strategy. In a way that sometimes it's taught or it's thought about, if we try to think about this without the open number line, we might see students just think, well, if I start with 59, plus 32, I'm just going to add 1 to this because that gives me 60. Much easier number to work with, but then I need to subtract 1 from the other number to compensate. That's why it's called the compensation strategy, to compensate for that. So 32 minus 1 is 31. So I'm going to do 60 plus 31. I'm going to leave this here. We're going to come back to this in a minute, this idea here, remembering that I can add 1 to the first add end and subtract 1 to the other from the other add end, and that compensation allows my sum to remain the same. We're going to come back to that idea because seeing it just like this is where some of the confusion might come into play. So now let's look at the second grade example. Just like other strategies that we've looked at, this is great because it carries over into larger ranges of numbers. So here, 639 plus 38. For this one, just to start with the other add end, I'll start with 38 this time. And so 38, I want to get to something that's a lot more friendly. And I can just make a small jump of 2 and get to 40. And adding to 40 is a lot easier than adding something to 38. But I was supposed to be adding 639. If I add 639, that's going to be too much. So instead of adding 639, I'm going to add 637. That compensation means that the total jump that I made was still 639. So when I add that 637, I get 677. So there's my sum. 639 plus 38 is 637. A great benefit of this strategy is it allows students, when in a situation where regrouping would be needed, if they were to follow a traditional algorithm, they don't have to regroup here. They can just use that reasoning to kind of get through and think about those numbers differently. The common difference strategy, very similar. Now we're dealing with subtraction. So we'll start again here with this first grade example, subtracting within 100. So 68 minus 25. So I'm going to put 68, okay, over here. And instead of thinking about, let's say, jumping back 25, I'm going to think about getting to 25. So we're thinking about subtraction as the difference between these two numbers. Rather than thinking about jumping back 25, we're thinking about what's the distance, what's the difference between 68 and 25. That understanding of subtraction is really important for understanding this strategy. So once we have that understanding, we can use this strategy. Now, seeing the difference between these numbers might not be super obvious to students at first. But if one of these numbers was more friendly, let's say if this number was 70. If that number was 70, judging how far away something is from a multiple of 10 or from a more friendly number is a lot easier than something that isn't as friendly. Typically, those multiples of 10s are really friendly numbers. But if I think about how far 25 is from 70, that distance is bigger. I can visually see on the number line that that distance is larger, so that wouldn't be the right difference. However, if I move this 2, if I also move this 2 over and think about 27, now this distance between 27 and 70 is the same exact thing. So if I can figure out this number, it will actually also tell me the difference between 68 and 25. And because that's more friendly, 70 minus 27, that's a little easier to think about. 70 minus 27 is 43. So now that's 43, which means the difference between 68 and 25 is also 43. Now, that example, no regrouping would have been necessary just to subtract. So maybe just thinking about 60 minus 20 is 40, 8 minus 5 is 3. Could have been a more advantageous strategy, but kind of showing that here that does work. This second grade example, though, if I were to subtract that as is, or think about place value separately, or if I were to subtract it using a traditional algorithm, some regrouping might be necessary. So let's use this common difference strategy to find the difference, or that distance. Remember, we're thinking about this as what's the distance between 536 and 99. We want to think about that distance. That's what our answer is going to be. Now, if one of these numbers was more friendly, it would be easier to tell the distance between these numbers. Now, this number is dangerously close to 100, and working with 100 is super friendly. So I'm going to move it over 1, put it at 100. But now, if I thought about the distance between 100 and 536, it wouldn't be the same. But if I make the same adjustment over here and make this 537, and now I'm asking, well, hey, what's the distance between 100 and 537? That's going to be the same as the distance between 536 and 99, which will give me the difference between those two numbers. And this is a lot easier to see. 537 minus 100 is just 437. And so finding that difference was a lot easier because it has a common difference with a problem that's a lot easier to see and just kind of think about mentally. Now, I want to jump back up to this example and kind of do the same thing with our subtraction to show why Without the open number line, if we just think about rules or we just think about the equation model, it can be a little confusing sometimes for students. So if I take 68 minus 25 and I apply this sort of model with this reasoning, 68 minus 25, what we did in this case was 68, we made 68 70. And so to think about getting to 70, we had to add 2. But to adjust so that our difference didn't change, just like we adjusted here so that our sum wouldn't change, I had to make an adjustment to the 25. I made 25 27, which was also adding 2. So that when I subtracted these, I got the same difference. Now, you might see the difference between how we modify with the common difference strategy and how we modify with the compensation strategy. In the compensation strategy, we add to one number and we subtract from the other. What we do to one number, we have to do the opposite to the other number. With the common difference strategy, what we do to one number, we do the same thing to the other. If I add 2 to one, I add 2 to the other. If I were to subtract 5 from one, I would subtract 5 from the other. And so when we add, we do the opposites. And when we subtract, we do the same. And so if students are trying to memorize those rules, where we apply them can sort of get mixed up, and they might apply the wrong rule at the wrong time. Later on, when they start working with fractions and we say things like what we do to the bottom, we do to the top. In algebra, when we're manipulating equations, we say what we do to one side, we do to the other. All of these rules start to sound the same. And when all these rules start to sound the same, it makes it really hard for students to apply them. The benefit of the reasoning, though, we can really still see in the open number line, and we don't need to worry about the rules because we can visually see, well, I've already moved this way. If I'm thinking about addition as making this big jump, now I don't need to make as big of a jump. If I were, let's say if this number was 62 and I jumped it back in order to get to 60, then I would see, oh, I went back. Now I need to add a little extra. So we can kind of visually see what's going on. When we think about subtraction as the distance between those numbers, we want to keep the distance the same. It becomes more obvious that when I move this number to the right, I got to move this number to the right. If I were to move this number to the left, I need to move this number to the left in order to keep the distance the same so that our difference when we answer the question stays the same. So that is for first and second grade, dealing with both ranges of numbers, the compensation strategy for addition and the common difference strategy for subtraction.